So today we're going to do Advent of Code 2023 day 8. To escape a sandstorm, we have a map, and that map consists of two parts. So first we have the direction we're going to take, and then there are nodes, and each node is linked to two other nodes. So for example, AAA is linked to BBB and CCC. And now we'll go from one node to the other node until we've reached node ZZZ. And we will go through our directions the whole time. So we'll start going right, then left, then right again, then left again. So if we exceed the direction we just started at the beginning. So we just take our direction as an array. Let's say R and L. And then we go from R to L. Then we would continue one step. We're out of bounds. So instead of going here, we just go back to R. Now the next step would be going from R to L. And then the same happens. And in each repetition, we check which of the two destinations to take. So if we have R, we're going to take the second one. If we have L, we're going to take the first one. So let's quickly go through that example. So we would start at A. Our direction is R. That leads us to C. Then we are at C. Our direction is L. That one leads us to Z. And now we are finished here. Since that's really straightforward, we'll just quickly go over the code. So we have a regex. The regex captures the first word, then the stuff we don't need, the second word, the stuff we don't need, and the third word. And getting the direction, it just went through the string, took the index of the first line and said I want a substring up to, but not including that index. Then we go through each match of our regex and we build up a dictionary, and the dictionary will have the start node as index and a tuple of left and right, also substrings of the next nodes that we can take. For the first part, we use a function called calculate steps to finish, starting at AAA. Calculate steps to finish. We just store the position we're currently at, count how many steps there are, and we're going to start iterating through our directions. In many languages, you would just say 0 here and then just increase 0 and take the modulo of the count of the directions. However, the indices of a string in Swift are not integers, so we can't do that easily. So we actually need to have a string index. And we're going to continue until we find triple Z. We get our direction from the index, either right or left. Get the destinations from the mapping. And then we decide if our current direction is R, we will go to the right. If it's left, we will go to the left. If we encounter something else than R and L, we've made a mistake parsing our input. So we'll crash the application here to make sure we will notice quickly. Then we will increase our step count. We will set the index to the next index. If our index is equal to the end index of the directions, we will just go back to the start index. And that way we will always loop through our directions array. Part 2 is actually a bit more difficult. Now instead of starting at AAA, we start at every node that ends with A. So in that case, it would be 11A, 22A. So we will start with two paths at the same time. And we continue until each part is at a position that ends with Z. So it's not continuing until each part was at a position that ends in Z one time, but all paths have to be at a position that ends with Z at the same time. We can also see that in the example. The path starting at 11A is actually 11B, 11Z, 11B, 11Z, 11B, 11Z. And the path starting at 22A will be 22B, 22C, 22Z, 22B, 22C, 22Z. Now at that point, all paths are at a position that ends in Z. So you could use the code from part 1, change it a bit and try to brute force it. However, down here you can see my answer. That's a 13 followed by 12 digits. That will take at least an hour. If your computer is at like 3 gigahertz or something, it'll take a while, and brute forcing is not the way to go. Now there's one optimization you can do here, and you can use the optimization always if there are things that are oscillating. So you can see here that that's always oscillating. It's always BZ, 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 BZ. And on the right side, that part is oscillating. So we have 2 on the left and we have 3 on the right, and the result is 6. And if you're quick at math, you'll notice that's actually just 2 times 3. It's the least common multiple of those two. So the important takeaway is if you have things that are oscillating, it'll always be a least common multiple problem that you need to solve. So instead of starting at AAA, we will build an array, and that array will be every item that finishes in A. For every start point we have, we'll calculate the steps to finish. It's almost the same as before, just one detail has changed. We're not looking for set, but we're gonna look to find a node that ends in set, and then just calculate the least common multiple out of these numbers. I won't explain in detail how the least common multiple is built. You can find that online. It'll use the prime numbers. For calculating the prime numbers, I've used the sieve of Eratosthenes. If you Google sieve of Eratosthenes, you'll find an explanation of that. Same for least common multiple. If you're interested in those things, just leave me a comment and I will see if I can make a video about that. So that was my solution for day 8. I hope you enjoyed it or at least had some fun, and hope to see you tomorrow.